Since the beginning of time, many civilizations have had their theories of light, from particles to waves to both together. Only recently have we found what we think is true on this topic. Tonight we are here to share our findings and research with you.
Over the years, there have been many theories about light. Back in ancient Greece, some scientists believed that our eye sent out tiny particles to collect information and bring it back to our eye. This was disproven since we can't see in the dark. Then they thought that the object resonates light to our eye. This was also disproven. Finally, they concluded that light comes from the source and reflects off the object and enters our eye. First, they thought in 1672, Sir Isaac Newton came to the belief that light was made up of strings of tiny particles. This was disproven since when scientists crossed two beams of light and showed that it passed 9 times through without any collision. So therefore it must be a wave. If it was particles, they would have collided and bounced in every direction. Take refraction, for example. Refraction is the behavior of particles, although it's not altogether impossible. Refraction is behavior of particles, although it's not altogether impossible that waves can cause refraction. Refraction is when, for instance, you take a pencil and stick it in water and it appears to bend. This is refraction.
The red light wave is the longest light wave in the visible spectrum at 780 nanometers to 620 nanometers. A nanometer is a 1/1000th of a meter. Next comes orange at 620 nanometers to 597 nanometers. And then yellow at 597 nanometers to 577 nanometers. And then green, 577 nanometers to 492 nanometers. Next comes blue at the second smallest on the visible spectrum at 492 nanometers to 455 nanometers. The last color on the visible spectrum and the smallest is violet with 455 nanometers to 390 nanometers. Those are all of the colors on the visible spectrum. And then comes ultra red, which is mainly used in heat lamps because of all of the thermal energy. Next, ultraviolet and VV ray. And then the next is X-ray, mainly used in the medical field. The smallest is called gamma wave. This is a wave that can kill someone.
Okay, so this is the sun. It lets off thousands and thousands and thousands of light waves every single second. So if you look at the sun directly, and I don't really suggest this, it kind of has this yellowy tint to it. That's because the sun actually lets off more yellow light waves than any other wave. Now, if you look around, there isn't all that much stuff that is yellow. So if the sun lets off more yellow white light waves, then why is there not more yellow stuff? So our whole world, here's the world, it's lovely, is made out of atoms. So if here's our atom, and it's got our protons and our neutrons, and our electrons are on the side. So electrons have frequencies, and so do light waves. So a frequency for a light wave would be, if here's how far a light wave will travel in a second, and here's the light wave going through that space, it would be how many of these peaks go through that space in that second. So that would be frequency. So pretty much what happens is a light wave with the same frequency as the electron will hit the object and will be absorbed into the electron. And that would be created into thermal energy. That's why if you leave something in the sun, it gets hot.
Yeah.
So that still doesn't determine what color we see. So the rest of the light waves that aren't absorbed into the electrons are pushed back up to the surface of the object and reflected back into our eye. Like if you look at a red chair, that's where all the light waves are absorbed except for the red, which is reflected back into your eye. So white is where all the colors are reflected back into your eye, whereas black is where none of the colors are reflected back into your eye. That's why people generally say that it's not a color, and why it's also the hottest color, because all the other colors are being turned into thermal energy.
When light enters the eye, first it goes through the cornea. Once it has gone through the cornea, it goes through the lens and then the retina. The retina is the light-sensing structure of the eye. The retina contains rods and cones. The rods handle the vision of low light, while the cones handle the vision of color and detail. Did you know that there are 3 different kinds of cones? The red, the green, and the blue. The red cone is more sensitive to the red wavelength, while the green cone is more sensitive to the green wavelength, and the blue cone is more sensitive to the blue wavelength. When I look at anything yellow, my red and green cones go off, sending signals to my brain telling me that the color is yellow.
So that's all we have for you today, but before you go back to your regular day-to-day life, I have a question for you. If you look at a blue shirt when there's no light, is it still blue?